Hello students, welcome to chemistry classes under this 2s block elements. Today we are going to discuss the general characteristic properties, chemical properties and physical properties of 2s block elements. First of all, the general characteristics properties of 2s block elements. So we know that the elements beryllium, magnesium, calcium, strontium and barium are present in 2s block elements. Beryllium, magnesium, calcium, strontium, barium and radium are the elements said to be alkaline earth metals. So what are the general characteristics of this alkaline earth metals? First of all, electronic configuration. So we know that beryllium atomic number 4, the electronic configuration 1s2, 2s2. All these elements having 2 electrons in their valence shell. Therefore, the general electronic configuration of alkaline earth metals are NS2, 2s2. Here NS2 is the general electronic configuration of alkaline earth metals. For example, beryllium is written like this: configuration of helium 2s2. Magnesium atomic number 12, electronic configuration 1s2, 2s2, 2p6, 3s2. It is written like this: configuration of neon 3s2. Similarly, calcium 20, so it is argon 4s2. Strontium, krypton 5s2. Barium, xenon 6s2. Radium, radon 7s2 configuration. So these are the electronic configuration of alkaline earth metals. Beryllium outer configuration 2s2. Similarly, magnesium 3s2, calcium 4s2, strontium 5s2, barium 6s2, radium 7s2. Therefore, the general electronic configuration of the alkaline earth metals are 2s2. The next is atomic and ionic radius. The second property is atomic and ionic radius. Atomic radii and ionic radii. So, atomic and ionic radii, as we compare it with the size of alkaline earth metals and alkali metals, these alkaline earth metals are smaller in size. We know that as we move from left to right in the periodic table, size of an atom or ion decreases. Size of an atom or ion decreases. So in the same group, the nuclear charge increases. Nuclear charge increases. As we move down the group, size of an atom or ion increases. So beryllium, magnesium, calcium, strontium, barium and radium. The size of atomic size of beryllium to radium, there it shows a regular variation called size of an atom top to bottom increases. Then ionic radii, they are exist as +2 oxidation state. So beryllium 2 plus, Mg 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus and etc. The radii also increases top to bottom. This is the variation of atomic and ionic radii in the case of alkaline earth metals. And ionization enthalpies. When we comparing the ionization energy of alkali metals with alkaline earth metals shows higher ionization energy, because all the elements having completely filled s orbital and so smaller in size. So due to the smaller size, the valence electrons are strongly held together, very difficult to remove one electron from the valence shell. Therefore, ionization energy of alkaline earth metals are greater when comparing with the alkali metals. As we move down the group, alkaline earth metal shows regular variation, that is regular decrease in ionization enthalpy. Because size of an atom increases, force of attraction between nucleus and the valence electron decreases. And here we observe two ionization potential. For example, we are taking magnesium, atomic number 12, electronic configuration 1s2, 2s2, 2p6, 3s2. Valence cell consists of 2 electrons. First electron is removed from the valence cell. It becomes Mg plus electron. That energy is called ionization energy 1. So ionize from Mg to Mg plus, we remove another one electron, gives Mg2 plus and electron. So this is ionization energy 2. So comparing the ionization energy 1 and ionization energy 2, the ionization energy 2 is greater than ionization energy 1. So but generally the successive ionization potentials are greater than that of the previous one. Successive ionization potentials are greater than that of the previous one. This value shows greater when comparing with the alkali metals. And the next property is hydration enthalpy. Hydration enthalpy, I already told you, in the case of alkali metals it shows higher hydration enthalpies. But comparing with alkali metals, alkaline earth metals shows larger hydration enthalpies. Larger hydration enthalpy is observed in the case of alkaline earth metals. So this is due to the smaller size and very greater tendency to absorb the water molecules. Therefore they are easily formed hydrated salts. So in the case of hydration, that is magnesium chloride exists in the form of 6 molecules of water, and calcium chloride exists in the form of 8 molecules of water. The salts with water, they are exist as hydrated compounds. So like alkali metal ions, hydration enthalpy of alkaline earth metal ions decreases with increase the size down the group. As we move down the group, the hydration enthalpies also increases. Down the group increases the size of an atom. Therefore the hydration enthalpy decreases. As we move down the group, size of an atom increases, hydration enthalpies decreases. So these are the some general characteristic properties. Now the physical properties of this alkaline earth metals. The alkaline earth metals are generally silvery white in color. It shows lustrous and relatively soft metals. However, these are harder than the corresponding alkali metals. Beryllium and magnesium appears to be somewhat grayish. These compounds, these alkaline earth metals shows lustrous property, and generally it is soft metals. This is a physical state of alkaline earth metals. Melting and boiling points. Alkaline earth metals, due to their softness, they show slow melting and boiling point. But comparing with the alkali metals, this alkaline earth metal shows higher melting and boiling point, because the 2 electrons in their valence cells are strongly held together by the nucleus. We are supplying enormous energy to break this bond. Therefore, the alkaline earth metal shows higher melting and boiling point when comparing with the alkali metals. Electropositive and metallic character. Because of the low ionization enthalpies, alkaline earth metals, they are strongly electropositive in nature. 2 electrons present in the valence cell are easily replaced. Therefore, it shows this electropositive nature. The electropositive character increases down the group. From beryllium to radium. Why this electropositive character increases down the group? Because as we move down the group, ionization energy decreases. Characteristics of flame coloration. Except beryllium and magnesium, all the other elements shows suitable color when we are exposing to flame or flame test. It answers flame test, that is calcium, strontium and barium. Calcium, strontium and barium are the three elements impart a characteristic color when we expose to Bunsen flame. Calcium shows brick red color, strontium shows crimson red color and barium shows apple green color. This is the reason for formation of color is due to the excitation of valence shell electrons. Excitation of valence shell electron. Such type of electron excitation not possible in the case of beryllium and magnesium. Therefore, it does not show or does not impart any color when it is exposed to Bunsen flame. Electrical and thermal conductivities. The alkaline earth metals have high electrical and thermal conductivity because all are metals and it shows excellent conductivity, that is electrical conductors as well as thermal conductors. Tendency to form bivalent ion. So due to the presence of two electrons in their valence shell, we are supplying certain amount of energy, that is ionization energy. The two electrons are easily removed and they source and it forms bivalent ions. That is beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, etc. This is the formation of bivalent ions. And these are some general characteristic property of alkaline earth metals. So under this module, we learn about general characteristic properties of alkaline earth metals. If you have any doubts, you may ask. Thank you.